and welcome to everyone to the Quantum Marketplace. This month's edition is about software for quantum computing, and all applications of quantum information science and technology. I'm excited to hear all the progress that's being made and to learn more about where quantum applications are going thanks to the work of a number of QED-C member companies. I'm Celia Merzbacher. I'm Executive Director of the Quantum Economic Development Consortium. And the Quantum Marketplace has really taken off in the past several months. So we're excited to be showcasing QED-C members through this program, this activity. And we hope you'll share information about the Quantum Marketplace with your networks and point them to the recordings from today and past Quantum Marketplace sessions, so we can help get the word out about what quantum is bringing to the economy going forward. So with that, I want to turn it over to Mark Wippich for today's program.
Thank you, Celia. So today we're going to discuss software for quantum, and we have 5 leading software companies that are practicing in quantum as well as other areas of quantum. So just a reminder to everyone in terms of logistics, everyone should be on mute except the speakers. And then if you have any questions, please send them in the chat and the speakers can address your questions. If they're fairly pointed and we have time at the end, we'll work to include some of those. Also, just so everybody knows, the recording of this webinar will be posted in the future on YouTube. Okay, so I'm going to give a few updates on the quantum marketplace, and then we're going to talk just briefly about some overview and trends that are going on in software for quantum. Then we'll get into the lineup and their presentations. Then we'll do a roundtable discussion and talk about the next webinar on the schedule. So if most people are familiar with this now, but we do have a directory on the QED-C webpage of all the companies in the ecosystem. And if you see a little icon next to their name, that means they've already presented in the quantum marketplace. You can click on that and go right to the video. Also, we do have a full YouTube channel. I think the webinar from last month should be posted very soon, which was Untangling Quantum Computing. That was highly attended. Go there if you haven't seen it. We're actually up at 112 subscribers now, so definitely if you haven't subscribed yet, hit the subscribe button. And that since we got over 101, we now have a custom YouTube link, which is just YouTube at Quantum Marketplace. Okay, so this is a courtesy of BCG from Matt. I just wanted to re-show this again from last month's webinar. And essentially, there's now over 100 use cases in terms of value creation potential with quantum computing. And so, what does this all mean, right? So, if we and I'm leveraging this from David Shaw from Fact-Based Insight. I think he did a good job of defining sort of what classic computing looked like in terms of the stack, and then what that morphed into in terms of, modern computing, in terms of high performance computing, and then how does that relate necessarily to quantum-based stack. And I'll bring this up later in the discussion, in the panel discussion, but this takes us into a little bit more into the details and some of the challenges with the quantum stack. So, and I like to bring this up again too, because there seems to be a common theme. Companies are asking, hey, when should I get in? Especially a lot of the larger companies, when should I get into, quantum computing and software for quantum? And so part of it, I think it's a two-pronged approach that people should be considering, which is, if you only get started once it's here, you may be too late to be, really tough to catch up. So fast follower may not really work here. And so really it's a downside risk mitigation, and having a seat at the table and having also so you get that downside risk protection, but you're there when the potential upside hits, and it seems to be the best option. So it's great to be paying attention to these trends as they morph themselves in. Okay, so the lineup today. So we're going to start with Yanni from QC Ware, who's the head of business development, and then we're going to go to Tim from Zapata, who's the chief evangelist there for their leading software. And then Tinian, the CEO of QunaSys, who's doing primarily quantum software for chemistry. And then Josh, who is the head of quantum software at Xanadu, and Mark, who's the leader at Quantinuum.
Okay, hi everyone. My name is Yannick Gambers. I'm the head of business development for Ware. And at Ware, as mission is to get enterprises and government organizations ready for the upcoming quantum computing disruption. Quantum computers will impact significantly the way we solve hard computing problems. We will be able to solve problems faster and better, get better solutions with quantum computers. And we believe that's going to be a very strong change in the way we do business, potentially creating new markets, new products, and new opportunities for current businesses. We also believe that the right time to start engaging in a quantum computing project is today, and that will effectively be your quantum insurance policy to insure you essentially against this upcoming disruption wave that's coming with quantum computing, right? So you don't want to wake up one day and find out in the news that one of your competitors is basically using quantum computing in a fundamentally different way, creating, as I said, a new product or a new market, a different category, and essentially eating your market share. By engaging today, by doing just a few things today, staying aware of what's happening in the market, you'll be able to not get blindsided and basically stay on top of developments. So at Ware, we do a number of things. We engage in professional service engagements, we produce software, and we also put together community events like conferences. So I'm going to talk a little bit about all of these three things in the next few slides. So we've been very successful in the last 3 years in engaging with customers. We've signed over 45 commercial contracts with over 25 enterprise customers. Most of these customers are essentially Fortune 200 companies. I'll talk about a few of them and the use cases in the next few slides. So most of these engagements are R&D projects, R&D professional service engagements, where our experts engage the customer and we help them understand how quantum computing will impact their business, different use cases, and more importantly, how do we bring quantum computer closer to today? What are the things we can do? How do we push on the boundary, on the state of the art of what quantum computing can do today? And how can we push that so that we can start using it sooner? So let's see some of these examples. So we've done a lot of work in manufacturing. We work with very large companies like Airbus, BMW, NEC, the Aishin Group. We've done things like software quality assurance, design verification, supply chain optimization, job shop scheduling. We've worked in life sciences with very large pharmaceutical companies like Roche and Boehringer Ingelheim on biomedical image analysis, and the central problem around drug design, which is how do drugs potentially bind onto proteins. We've also worked in material design, and we are working quite a bit in all these areas. We've worked here with the the material design spin-off from Bayer called Covestro on polyurethane and the design of other plastics. And we're also working on battery design with a large automotive player. We're working with several financial services customers, several large investment banks like Goldman Sachs on derivative pricing, hedging, trading, a few other problems. And we're working with other retail banks on things like customer retention. We've also done quite a bit in energy with BP and Total on power tolling and crude blending. This is our product. It's called Ware Forge. Everything you see in this slide is bundled and integrated into Forge in one cohesive product. But we are highlighting this top stack, the application and algorithm stack, because that's essentially where Forge provides differentiation. Those are the unique and performant algorithms that you can find on Forge, and you can't find those anywhere else. These are algorithms that we've discovered on our own or through partner engagements, and we distill them into the product. The rest of the stack here, we're getting essentially from partners. And the last thing I'm going to say is around Q2B. This is the conference we've been putting together for the last 5 years. It's really the largest business conference in the quantum computing space. Q2B as in B2B or B2C, that's where the name comes from. We're running it every December in California, and we bring together industry, academia, vendors, software and hardware vendors, and government, and essentially the end users to figure out what's the next milestone in the quantum computing space. Thank you very much. Please reach out if you have any questions.
So Zapata is a leading software company at the forefront of the quantum computing revolution. Our heritage is in quantum science, and we're making that expertise useful to our customers with our platform that's engineered for enterprise scale and complexity. Our minimum goal is to outperform our customers' existing classical solutions in a way that gives them competitive advantage even before quantum advantage is available. This positions them to reap the benefits of quantum computing as it comes online. Our offering is built on our IP and research across algorithms, use cases, and hardware expertise. And then this expertise is made available to our customers through our platform, Orchestra. We collaborate with our customers to build quantum-ready applications. So for now, these are classical applications in machine learning and optimization, which are forward compatible with the quantum hardware to come. A selection of customer examples we can share includes BBVA, BP, BASF, and Andretti Autosport. The Orchestra platform addresses the challenge of building and deploying quantum-ready applications on top of both classical and quantum substacks, while remaining cloud agnostic, quantum hardware agnostic, and integrated with all the major quantum and ML libraries. This flexibility ensures our customers best utilize underlying hardware for their applications. These end user applications focus on use cases such as route optimization, financial portfolio optimization, generative modeling, and more. Orchestra suites are Zapata proprietary libraries that serve as building blocks for applications alongside the quantum ML and other open source libraries that are also integrated. The Orchestra runtime is the smart backend that orchestrates the execution of compute. It connects it with data and manages all the resulting outputs. And Quantum Ops is a growing set of tools to help businesses tune their usage of compute across quantum and classical, with the goal of controlling costs and optimizing usage of the underlying resources. Lastly, Orchestra Studio houses the user interfaces for teams ranging from research to operations to control and manage these capabilities. We're positioning our customers to win the quantum revolution, not get disrupted by it. So here are two use cases where we can share pieces of what we're doing. Both are customers of Zapata's enterprise solution and engagement model. BP. So we've had a long relationship with BP that started in chemistry research and how to make quantum viable for chemistry over various time horizons. The variational quantum eigensolver, or VQE, which two of Zapata's co-founders helped invent, is a well-known algorithm that can simulate molecules on a quantum device. In this project, we used two proprietary methods to shorten the VQE runtime. Despite this, VQE still takes far too long to run on a quantum device anytime soon. But BP has a clear sense of how to interpret hardware company roadmaps in terms of impact on their business. Now, we can't share what else we're working on with BP, except to say that it is a portfolio of high-impact use cases across their business, and it anticipates a range of quantum device maturity. You can hear about some of our work on our YouTube channel and just look up Q2B talks. Andretti Autosport is a newer customer, and they're taking an infrastructure-first approach. We are upgrading their infrastructure with Orchestra and then exploring and piloting applications with the goal of helping them win races. With this environment, as quantum hardware matures, the collaboration can test approaches using quantum technologies alongside classical methods and resources. We're here today to find customers who want to go past the research phase, who are playing to win in quantum and secure a competitive advantage. Our engagement model drives towards applications in production. Now, these apps don't have to be quantum yet. They can be quantum inspired or all classical now, while being forward compatible with the quantum hardware to come. By running Orchestra, we'll be able to swap out compute backends as the hardware from our partners matures. Our customer relationships run deep and combine application development on Orchestra with capability building and training through access to our scientists and engineers. Thank you.
So I will talk about the chemistry applications using quantum computer. So what QunaSys is doing is like we are building software for chemistry calculation without people having the deep knowledge of quantum computing or the knowledge of quantum algorithms. So for example, like the sodium and water, that the explosive chemical reaction that is only recently understood. And one important famous example is like the pharmacomolecules that for nitrogen fixation, the mechanism is unknown. So we are tackling how can we understand the mechanism of this chemical reaction and how to design new materials using the quantum computer. So QunaSys is collaborating with like hardware vendors and hardware startups and other academias over the world. And also we have a large consortium called QPark. This is the consortium we launched in Japan. This QPark stands for Quantum Practical Application Research Consortium. And what we are doing is in the more than 50 Japanese company, it's like let them learn what the quantum algorithms is, and we together build application with them. And I will share several use cases developed in this consortium. So I will talk about our product, Kamui. So how this Kamui different from like open source software like the QuizKit is like using Kamui, the end users don't have to care about the quantum circuits. So they can just focus on industrial problems. So how to use Kamui is like you just input the molecules you want to test and just specifies quantum algorithms you want to use, and also specify the molecular property you want take, and that throws to our system, and our system automatically construct the quantum circuit and evaluate using the simulator or the real quantum devices and returns to the end users. So since in this Kamui, there's a lot of features to calculate a lot of physical properties, it enables end users to run a wide variety of industrial relevant use cases. So these are the examples made using Kamui. So for example, one thing, the most important is like understanding of reaction path search, or other is like molecular dynamics simulation, vibration frequency analysis, photochemical spectrum, data dynamics, and also we have an algorithm to calculate periodic states. So it enables users to calculate the band gap of the periodic systems. So I will list up one example, the reaction path search. So this is the example done in QPark. That the consortium I mentioned before. So this is the example by the group of Mitsui Chemical, JSR, and Bridgestone and HPC systems. So what they worked on is one algorithms called GRRM, stand for Global Reaction Route Mapping Algorithms. So this is conventional algorithms that you used with conventional quantum chemistry software, but they changed the backend to our Kamui, and they use and combining with these two technology that they tested what the quantum algorithms can enhance these GRM algorithms. And actually the findings really interesting is that they found some reaction paths that couldn't find using the conventional software. So they're like working, they find like a really interesting use cases and working deeply in doing research right now. So that the Kamui is helping users to find the potential use cases and learn the state-of-the-art quantum algorithms. So this is how we are helping our end users. All right, so in the end, like this is our team. So in QunaSys, we have more than 28 scientific paper published, and Kamui, there's more than 3 million API access since it launched, and that is used in more than 50 companies in the consortium in Japan. And we are expanding to over the world right now. All right, so like the final comment is like that in QunaSys, we are helping users to boost technological adoptions. And also like we are collaborating with users using our algorithm expertise and work with users to build industry relevant use cases. And we understand that our algorithm, like mainly based on variation quantum eigensolver, has a lot of problem, and we are working on fundamentally renewing these algorithms, and we are happy to work with users to upgrade the algorithms together. Yeah, thank you.
Well, hi everyone. My name is Josh Isaac. I'm head of quantum software here at Xanadu, and today I'll be talking about our PennyLane software stack. So what is PennyLane? PennyLane is an open source framework for programming quantum computers. We created PennyLane back in 2017 because we noticed there was something missing from quantum computing. There was no quantum framework that integrated seamlessly with the existing scientific ecosystem while providing flexibility and intuitivity. Researchers didn't want to use monolithic, already crafted algorithms, but they wanted to explore and prototype and create their own. More so, existing research and exploration relies daily on mature tools such as machine learning frameworks like PyTorch and TensorFlow. And we want to make it possible to keep using those established tools, but introduce quantum computing and quantum hardware into those workflows. Especially because with near-term devices, algorithm development is not purely quantum, but includes aspects of quantum and classical. So PennyLane takes this into account. It allows you to make your existing workflows and models quantum aware. In essence, training a quantum computer the same way you would train a neural network. So since 2017, PennyLane has grown a lot, with a focus beyond just machine learning to applications, optimization, and education. Everything we do is open and in the public, and we have developed a huge focus on our community as well. With such a nascent field, we want to hear how people are using PennyLane and learn what we can do to help make PennyLane a tool that drives forward research and exploration. So we're not just a quantum programming framework, but we're also a community and an educational resource. Another thing that we really wanted to do with PennyLane is that while we are in this near-term era of quantum hardware, not all quantum hardware is the same. We have quantum hardware from different vendors, and we have quantum hardware across different architectures, from photonics to trapped ions to superconducting qubits. And we are still in a stage where certain architectures might be better suited for different applications. There's no one particular architecture or device that we want to lock ourselves into, but we want the ability to play around with all of them. Not only that, but we want to include multiple hardware architectures in the same application or the same model. Something like the ability to train a trapped ion device and a superconducting qubit device simultaneously. So we've taken a very much a hardware agnostic approach with PennyLane. We want to support as many different architectures as possible. And at the moment we support 7, which is a leader in the field. And we also want to ensure that you can mix and match, change them easily, and use multiple at the same time. So something else we acknowledge is that quantum computing is difficult. It's a hard field, which is why we have also built up alongside PennyLane this community so that we can sort of ride this wave together and help each other out. So these stats just show where we are today with this community. So what we've been doing is establishing engagement across different areas. So across software, social media, direct company engagement, and also events. So something I want to emphasize is that PennyLane is bigger than just us here at Xanadu. So we have our annual developer conference, QHAT conference, which is an event for engaging with us and fostering the quantum programming ecosystem as a whole. So we want to bring in companies across the spectrum, non-profit organizations, universities, to celebrate the whole quantum programming ecosystem. At the same time, we've been working hard and exploring partnerships with PennyLane and signing up startups who are interested in the PennyLane platform to build on PennyLane to provide additional services and products. So these include startups like Menton AI and Agnostic. At the same time, we've been working with other companies who have been backing our vision with PennyLane, such as AWS. Something I can share with today is we've just announced new work with BMW on tensor networks, a new approach to building quantum circuits. So part of our open ethos and our drive on a community, not just a programming framework, is we realize that because quantum computing is hard, we want to share the lessons we have learned and the things you can do with quantum computing and quantum programming. So we don't just want PennyLane to be that flexible tool to do what you need it to do in research and development, but we also want to provide the resources to go from beginner to expert just from using PennyLane. So on our website, we have a large range of quantum computing demonstrations and tutorials accessible for free. I think as of this morning, with the BMW Tensor Network demonstration we uploaded, we have 80 demos. And these range from learning the basics of quantum programming to applications and optimization and quantum chemistry, as well as learning the theory and fundamentals of quantum computing. So you can best place where quantum computing will fit into what you're building and what your needs are. So yeah, we'd love to get in touch with you to find out how PennyLane can help build what you're looking to build. Thank you.
So hello everyone, I'm Mark Jackson. I'm the quantum evangelist at Quantinuum, which is the recent merger between Cambridge Quantum and Honeywell Quantum Solutions. We are now the largest quantum computing company in the world. We have over 400 employees worldwide. So we obviously have a strong presence in the US and the UK. We also have offices in Japan and Germany, and soon to be opening up one in France. We have applications in every area that's been talked about today. So this includes chemistry and machine learning and optimization and even natural language processing uniquely. But what I'm going to talk to you today about is Ticket, and this is the glue that keeps everything together. So Ticket is the liaison between quantum algorithms and interfacing with the hardware or simulator. Now, we realize that right now there are many choices in quantum programming languages. This includes IBM's QuizKit or Google's CERT or Microsoft's Q#, among others. And there are many platforms, and I've listed a few logos here. So these are some of the major ones, and there are many, many others, and this increases every week. The problem is that using one of these languages tends to limit you to the platform that you use. And in addition, it doesn't always run as efficiently as you'd like. And especially in this NISQ era, this could mean the difference between your program working and not working. And this is why we developed Ticket. So Ticket is a quantum software development kit, which is completely agnostic with respect to both the language and the platform. So you can use any of the languages on the left-hand side and execute your program on any of the platforms on the right-hand side. And furthermore, Ticket will automatically find the most efficient way to execute your program. And you don't need to know the details. Ticket will do all this for you. You simply add one line to your code saying, use Ticket to compile my software, and Ticket will do the rest. So you can keep your existing software in QuizKit or whatever, and you just indicate which platform you want to run it on. Now, there's two ways that it does this. The first way is by optimizing the circuit itself, and this is independent of the hardware. And I'll give an example in a second. And the second way that does this is it does use the details of the hardware and it solves these constraints. And again, I'll give an example in a second. So these are some of the optimization procedures that Ticket does on your circuit. And you see that there are several examples here. The upper left-hand corner is an obvious example of two C0 operations in a row canceling each other out. And so this makes your program run a little bit faster and be a little bit less likely to make a mistake. And these others are all, again, mathematically identical. It just takes a little more time to work this out. If you're curious about the mathematical details, I've given an article referenced here. So the second part of this, as I mentioned, was solving the constraints specific to the hardware. And there's a few different components to this. So one component is Ticket is aware of the platform of how the qubits are connected, all the couplings between them. And so Ticket will automatically route the information around between the logical qubits and the physical qubits to maximally optimize this. It also makes the translation between the gates that you may have used in your circuit and those which are native to that platform. And then finally, any sort of delaying measurements that it can do if your platform supports that. Of course, we use Ticket for our own internal quantum algorithm development, but many other groups have been using this. This includes IBM and Google and even CERN. And this includes here on the screen some of the articles that have been written. And almost in every case, you will see an increased efficiency in running your software using Ticket. We are constantly updating it. We always have new versions, and last September, we made a major change to it. We made it open source. So it's not only free to use, you actually can inspect every line of code yourself. So if you have some clever idea, you're welcome to contribute to this. If you have your own hardware platform, of course, you can write your own extension so that people can write software and run it on your platform. This is the GitHub repo. If you'd like to take a screenshot, I welcome you to do so. This is how you download it from GitHub, and then you just install it using the usual pip install. And so if you have any questions, please feel free to get in touch with me. This is my email address and the ticket support email address as well. Thank you. Okay, so we had the 5 companies present, and one thing I didn't note earlier is that 3 of these companies, QC-Ware, Zapata, and QunaSys, are approaching from software solution, versus Xanadu and Quantinuum have software solutions, but they're also providing hardware platforms, but also making it so that they can run on other hardware platforms. Okay, so that said, so I want to start with asking a question of Yanni. What are your customers? We've heard a lot of hype in quantum computing hardware, quantum computing software. It seems to be getting a little bit further than quantum computing hardware. What are your customers getting out of your software solutions today?
Yeah, so I think the key thing is knowledge and skills for how to use basically quantum computing in the future. I think very famously, I believe it was one of the quantum experts at JP Morgan that said, well, even if you were to give us a fully functional, fault tolerant, but like really good, really large quantum computer today, we wouldn't know how to use it, and we wouldn't be able to use it because we don't really understand kind of where its impact is. So really the most fundamental thing are skills. Now, I also think though, there are changes happening in the market, and we're seeing that with quantum inspired, quantum ready, according to Zapata, and quantum hybrid or quantum, I don't know what the best way to call it is, but there are all these names flying around. Essentially software that's classical today and will prepare people for quantum, like do a certain task today classically, and then get ready for what quantum will do in the future. So I think that's a major change that's happening in the market that's also impacting how users are using software that a lot of companies in the quantum computing space are developing.
Great. Thank you for that. Josh, care to comment on this?
Yeah, sure. So I think one of the big things with PennyLane, I suppose it's slightly different from the other software services in that we're more open source quantum programming environments. But from talking to customers, I think the thing that we're providing here is the ability to rapidly prototype in an area where you have full flexibility and you can learn and explore as you're going. With quantum computing, I think it's still such early days. There's still so much R&D happening to determine what the applications are and how they look and whether they're even suited to the applications we want to solve in industry. So with PennyLane, we're providing customers that ability to use an environment they're familiar in. So if they're coming from machine learning pipelines and they want to explore how quantum fits into this, have an environment like that where you can explore and learn and understand and see what the differences are on the quantum computing side and see how it interfaces with classical computing and see what the nuances are. So if you have a large amount of data, that might be technically difficult to embed in quantum systems at the moment, and what are the workarounds around that, and how can we interface with our existing tool set in ways that are advantageous with quantum hardware.
Great,
so,
thank you.
Yeah.
Mark, how about you?
Yes, so we are only interested in applications which we think we could make a difference in the next few years. And so kind of by definition, we're hoping our customers will also be looking in the short term. And so, yeah, so when we work on these proof of concept projects, it's usually a year or two, the projects last. Of course, we use Ticket to do this. We now run it on our own hardware. Previously, we used several different platforms, and then we evaluate whether we think it's feasible to scale. And several of them are, and we've continued to work with these projects. And these have included chemistry, machine learning optimization, and even natural language processing. So, yeah.
Great. Tinian, care to comment on this?
Yeah, so so one thing is that as Yanni said, the customer is still learning what the state of the art algorithms, etc. And what we are also doing is the customer identifying that there's even today's state of the art algorithms have a lot of problems. So they identify problems, and we working with customers, how can we fundamentally improve that algorithms? So that is what they're getting.
Yeah, great. And you're also working with a lot of researchers right now, right? In chemistry?
Yeah.
Yeah, yeah. Okay. Tim.
Yeah, thanks, Mark. Certainly, a lot of what everyone's saying here rings true for Zapata as well. I think fundamentally what we're bringing our customers is de-risking of quantum. And this comes in two ways. The first is in terms of understanding what are the intersections between their business and quantum. And then within that understanding, where are the inflection points? So for a given problem, what are the key hardware metrics they need to be tracking to understand when these hardware roadmaps are really going to have an impact on their business. Then on the second in terms of de-risking is understanding from an infrastructure standpoint, what are the types of investments they need to be making that they are not going to be disrupted as quantum comes online. And then in the meantime, it turns out a lot of the upgrades that you can be making to be quantum ready in terms of infrastructure and algorithms and the sophistication of your broader analytics platform are actually really valuable today. So there are some near-term wins, even in this pre-advantage world, that our customers can enjoy.
Great, thank you. And Tim, I'm going to come back to you in some of our prior discussions.
Mm-hmm.
You know, we talked about the stack, right? So this is courtesy of David Shaw. I took the liberty and, lifted, as I mentioned, your stack. And I think you've got a lot in here that also applies to the other companies presenting. And I think, we've got Penny Lane in here. We've got, all kinds of things in here, right? So when you put this together, right, so you've got quantum hardware here on the left side, you got classic on the right side. What was your thinking here, and how does this how do you see this evolving in time?
Yeah, great question. Over the years working in quantum, I think one thing that Zapata's learned is that really, quantum will never be operating in isolation, right? And so we see kind of the quantum stack is actually really a substack that's going to be operating next to a classical substack and probably a bunch of others as well, right? It's even to talk about quantum in general is not exactly right. I mean, actually what we're talking about is, ion trap devices, photonic devices, superconducting devices with plus sub flavors within each of these, and then many more. And we could go on, probably, I don't know, a dozen or something of these varieties, each which is going to be really particularly good at certain subclasses of problems. So when we think about the challenge that, the enterprises are going to start facing, there's just myriad of choices of where you're going to send your compute. So what we've tried to do with with Orchestra is kind of take one step up and think about how for sure, what are the quantum specific challenges that are coming? But in addition, what are the challenges that are going to come when you actually have to make this work and you have to have it tie into your data storage, to your data lake? You need it to be, running on, the cloud, your cloud of choice, potentially on-prem, right? It's integrating potentially with HPC investments you've already made. And it gets quite complex. And we're really trying to then span all these substacks to create a single unified platform that really lets you operate in an intelligent way across all these opportunities and these technical opportunities.
Great, thank you. Yanni, you care to comment on this? In terms of how you're looking at this or how QC-Ware is looking at this?
Yeah. So I think both of these slides, both of this is accurate, right? And what Tim just said, quantum will essentially coincide with coexist with the classical resources, and it is important, right? It is important to have frameworks in place to make it easy to use the best of the quantum world and the best of the classical world, and kind of have seamless integration for our users, right? And experiences for our users. As I mentioned, I mean, we concentrate really on the very, very top layers of this stack, right? So I don't think there is anybody that's actually creating real end users applications at this time in the market because of the hardware maturity. I don't think it makes sense at this point.
Now we're going to get to that point in a little bit too. So you're going first on that one.
Okay, good. Yeah, we're concentrating on the algorithm side of things. We think that's a way to bring quantum closer, right? And that's kind of how we work with our customers, because effectively, you know, the way that I see it is that this race, right, coming from both sides towards the same endpoint, which are practical applications. The hardware developers come at it basically by building bigger and bigger computers. The software guys, we are coming at it by basically using less and less resources, quantum bits specifically, to get the same or better results, right? So by essentially on the software side, creating an algorithm that uses, let's say, 10x fewer resources is equivalent on the hardware side to creating a quantum computer that essentially is 10x larger, right? But you can do it outside of a lab. You can do it with just a couple of guys sitting in front of a whiteboard. It's hard to do it, don't get me wrong. I mean, it takes a lot of brain power to do it. You don't need the lab. You don't need like all the other things that go with hardware, right? And that's exactly where we're concentrating with our customers.
I see. And then, Mark, I think this is another area that it would be great to hear from you on.
Yes, so our stack is a little bit more vertically integrated. So in some ways it's similar that we have applications and then algorithms, but of course we've built our own SDK called Ticket. And so a lot of our algorithms work best with Ticket. And then at the bottom, of course, we have our own hardware. And so even though our software is hardware agnostic and our hardware will run in anyone's code, of course, it works best when you use our algorithms on our SDK, Ticket, and our hardware.
Mm-hmm. Great. Thank you, Mark. Tianyin, you want to comment on this?
I have a little different view. So what I think is like the IBM, what they were, for example, building is like they are building like the one called Qiskit runtime. So that is built by the, how to say, run all the applications on the IBM classical devices, and that is co-located with IBM the real quantum computer. So I think that is the future. So I think we have to move from these models. So I think this model mainly that we will just roll from our computers to using API to IBM, like just same quantum circuit, and that is extremely slow. So I think that's kind of, in these 2 or 3 years, I think we will see like we are all moving to the hardware vendors cloud. That is what I'm thinking.
I see.
But the layer is the same. Yeah.
Yeah. Okay. All right. So in terms of, yeah, I want to talk about this. So in terms of getting in, right, what are the best practices? I'm going to start with you, Yanni, of getting into software for quantum. And part of this also, so how, if the quantum hardware is not fully there yet and the software is making a lot of progress, you mentioned that you're already working and have a lot of contracts with customers. How do you work with them? And I think it's really, I thought that was sort of a unique position that Ware has when we talked prior. How are you getting, Fortune 300, Fortune 200 and others to work with Ware now?
Yeah, I think the when discussion is very interesting. So when people ask me that, when potential customers ask me, okay, why should I do it now as opposed to waiting? I always tell them, hey, look, how long did your last digital transformation take? How long did it take for you to hire data scientists and integrate AI and ML into your business processes and get ROI out of it? And the answer is typically years, right? It typically takes 3, 4, 5, 6 years for companies to do things like that. And so the next wave of digital transformation, which will include quantum, will also take a few years. And so if you don't start today, then if you don't start essentially building the expertise, getting the experts in to come to your company to understand what are the use cases that will be impacted and how exactly to integrate these approaches into your processes, then then you won't be ready in time, right? So so that's kind of the why or the when question. Now, in terms of kind of what we're offering them and getting them on board is basically this very kind of unique perspective on what quantum can do. We push the boundaries, and I think that's what they like. So at the end of the day, our customers are getting basically a new perspective of this timeline, right? We're pushing on the boundaries and kind of try to essentially shorten the timeline to quantum advantage. We publish a lot of papers with our customers. We go after patents together. They gain some IP out of these engagements, so they gain a lot of practical things that they can use in this transformation.
So Yanni, then you're doing collaborative R&D with them, right?
Absolutely.
You're doing R&D development projects. You have partners. Great. I don't think everybody knows that. All right, Tim, what do you think of that? How do you approach this?
Yeah, so in terms of the urgency, I think it's now been said, but essentially companies want to be starting now, if only because of the talent, right? There's just not going to be enough people, especially once things really start cooking. So the talent can be both on an internal side in terms of getting as far as hiring, or in terms of just building the external relationships that you want to have. We did a survey of 300 global executives at the end of last year, and 69% of those companies are looking to adopt or planning to adopt in the next year. 51% of those are including hiring in that. So there's already going to be moves towards hiring. On top of this, 96% of all companies asked said that they would be looking to some sort of trusted technology partner to help them in this. These relationships are critical to get established, getting comfortable, and starting to think about, who can help you as these things unfold. Then when we look at, once people engage with us, what the process is, it depends a little bit on how much they've thought about quantum already. But if they're starting from the beginning, we're going to begin with a use case evaluation where we're going to come up with potentially dozens of use cases that could potentially affect their business. And then we can start prioritizing those in terms of looking at where they might be landing on the roadmaps, and then start focusing in on some of those near-term cases to really start to wring out the details for the specifics of that company in terms of driving that towards actually an application that they could be running in production. And again, we take the approach that just because you may be waiting on something specific in quantum, it doesn't mean there aren't unique or new algorithms that could have a positive impact in the near term.
Great, thanks, Tim. Tinin, can you comment on this too? What are you telling your customers when they ask you this?
Okay, so like we are working with the chemistry application. So the chemistry of pharma, that the important thing is that you find the new materials or the drug and patent that at the first. So that is kind of they're interested for that, so that they need really new tools to find new potential materials. So they really understand like that the current experimental style R&D won't work, so they need some computation, but the supercomputer cannot give the answers they want. So it will be like it will be really natural for them to start learning about this technology and see the potential if this technology can be used for them or not. So that
it's curious that you guys are focusing on chemistry, and we've heard from the quantum guys like Deloitte and Accenture and BCG how chemistry is material science potentially is one of the first large markets for quantum software and quantum computing. I'm curious, are your customers that you're working with, are they excited about this? Are they excited about the potential?
Yeah, they are. Like if we have a really high fidelity 50 qubit devices, they can run something classical cannot. But I don't think that NISQ devices will happen. So we are focusing on more like 1,000 qubit size and maybe potentially do partial error corrections. So kind of, yeah, that size is like, and that is rather close what we think compared to other applications.
Great. Josh, are you there still?
Yes, I am.
Yeah, Josh, I'd like to know, since, and then I'll ask Mark after this, but since Xanadu is doing software, and I know that it's your side of the business, but you're also a physicist, right? So it'd be great to know how is Xanadu approaching this question with customers?
Yeah, no, it's a really good question. I agree with something that came up earlier, in that initial R&D collaboration is, I think, the way to go at the moment, and the way we approach approach this question.
Yeah.
A big part of it is trying to understand exactly what the problem is on the customer side. It's not so much that I think we're not at a stage, and it won't be for a while, where we have big quantum algorithm solutions that are the solution to various problems in industry, and you can sort of shop them around. We're very much in a stage where we still need to understand the problem from the customer perspective, explore what the solutions are, and it will very much likely be a hybrid solution. So something that's hybrid quantum classical, potentially mostly classical in some cases.
Yeah. Thank you, Josh. Mark.
Yeah, so when customers express an interest in working with us, we ask them to identify a few use cases of bottlenecks that they believe that classical computing gives them. And so then our scientists then take this and try to identify, as I said earlier, cases where we think that we could make a difference in the next few years, not in 20 years, but in the next few years. And so then when we converge on a project, we then write the algorithm from scratch, we write the application, we test it on hardware, and then we evaluate whether we think it's worth scaling or not.
Okay, great, thank you. Yeah, and I want to start with Yanni here. What question are you hearing most from your customers today?
Yeah, I think it was also asked one of the last questions in the chat here, which was basically, okay, well, what's the no kidding number of qubits and fidelity that is needed for us to actually get to something practical, something that classical computers cannot get to? And I think that's the key question, and it is hard to answer. It's not very straightforward. So, we can give ballparks. The reason it's hard to answer, it's really dependent on the use case, right? So for some of the chemistry problems, I do agree with what Tenin said, and the analysts are saying basically we share the same perspective that chemistry simulation will be indeed the first application. Some instances, right? Some instances, we're not talking about everything in chemistry simulation. But we do think that a few hundred qubits with maybe 3, 4, 5 nines of fidelity, that's the ballpark range where you have to be at to start essentially solving large enough molecular systems that are interesting for industry, and also systems that contain certain types of molecules, maybe metals, maybe other things that current chemistry simulation approaches basically cannot really accurately simulate. So that's really the most near-term thing. Now for other places, for other areas, for other use cases like Monte Carlo simulation or optimization or machine learning, I think we need to get basically to maybe a few thousand qubits and possibly the same or even higher fidelity before we can execute something that classical computers cannot do at this stage. And I think really the other thing I want to share my perspective on optimization, which at some point was considered to be kind of one of the most near-term things, but as we all know, all of optimization is heuristics, right? We can't really prove anything until we empirically see it happening many times. And I think that's kind of the hard thing about optimization, where we'll have to basically, quantum computers will effectively have to solve a few very hard optimization problems that classical computers can, and that's when we can declare victory. With some of the other things, I think it's easier to predict a trajectory. I think with optimization, it's going to be a little harder.
Yeah, thanks, Yanni. Tim,
Yeah. So yeah, this is an interesting one. We actually at Zapata would probably disagree with this. We see chemistry as actually one of the later applications, as it does require. I mean, unless you're talking about very, very small molecules, because of the connection between the electron count and the cubic count, we think that the big impacts on chemistry will be, they will be big when they come, but it will be a little later. We are much more excited about quantum machine learning applications right now, but it's in a narrow case. And in particular, we're looking at generative machine learning and how the quantum device can be used as a sampling device to feed this. And then on top of that, and I posted a paper in the chat around this enhancing combinatorial optimization. And the trick with this approach is actually using generative machine learning as a piece of a classical optimization loop. So for sure, heuristics are the name of the game with optimization, but so as the rule goes, same goes for like machine learning, right? It's all heuristics, and they can be very, very impactful without mathematical proof. So with this generative machine learning technique, we think there's an opportunity, again, with a largely classical system, to take advantage of the quantum device to represent a distribution and then sample from it in a way that can be very impactful for optimization loops.
Yeah, thank you. Mark, what are you hearing most from customers today?
Yes, yeah. Many companies have asked us when quantum computers can beat classical computers. And of course, we tell them this very much depends on the application. We expect that in as soon as 3 years, this will be possible for some applications. And unfortunately, some clients then respond, well, okay, we'll come back in 3 years. But of course, this is the wrong answer, because if you do that, you're too late. There's many other companies who are already investing large amounts of resources in this, and they're the ones who will benefit most from quantum computing. It is not too early to start now. It takes time to develop the applications and also kind of the quantum muscle, if you will. And so now is the time to invest in this if you're going to take advantage of it in a few years.
Yeah, I mean, that gets back to, many have said that they waited too long to get into AI and they paid the price, right? But this one's going to be harder, right? Josh, what do you think of this? What are you hearing most from customers today?
So maybe I come into this from a slightly different perspective, because with our existing customer involvement, I normally come in at the stage where the problem is the direction we want to go in is more or less decided. And I'm helping more with the low level, how do we make Penny Lane work for this?
How do you implement it? How do you implement it?
Yeah.
Okay. All right.
So in this particular case, things I'm hearing from the customers is that they want to work in an area where they don't have to be locked into particular hardware, and in a lot of cases as well, aren't worried so much about the existing near-term hardware in terms of restrictions and issues. They're thinking more holistically how this will scale as bigger hardware devices come online, better error mitigation devices come online, and are looking more to prototyping and explorations in that area. So the thing I'm hearing more from customers is more about the abstraction level, what they want to work on, I guess, once they've determined the problem they want to explore.
Right, great. Tinian, you want to comment on this too?
Yeah, so like our customers, there's a lot of customers, not all the big customers, but also like the mid-size chemistry company. So what they the comment is like that they find some hope and find some disappointment. So if it says like quantum computer first, they will think that every application will be faster, but the findings that they are, they find out like a lot of things, and especially right now it will not be fast. So kind of, but I think that is really good thing. So that is kind of they are at the same line with us, and like we are like, and together find like how can we really use this technology first, because all the technology will not change world in one day. It will eventually start from niche application and eventually make the become a broader application. So kind of starting like the finding niche application, or like so kind of that is what our customers' comments.
Okay, I'm going to go off here a little bit from my other question and ask one that came up in the chat. So someone in the chat asked, could the panel comment on implementation of quantum-inspired systems, i.e. quantum formulations running on classic hardware built to accelerate and improve computational solvers? Janu, you want to go first on that?
Yeah, so I think we need to be a little bit careful with, so the name quantum inspired is primarily used for these optimization problems, right? And optimization solvers. Yeah. I kind of feel that with the way it has been approached so far, we artificially constrain the way the problem needs to be formulated. I mean, we kind of use these cubo formulations, and so you're almost getting the worst of both worlds with quantum inspired. You don't get the power and kind of the scale that you can get with classical. So you can you basically, it's not the state-of-the-art classical solution, this quantum inspired solution. And it's also, does very little to actually prepare you for quantum. It basically just kind of helps you do this just formulation. So I'd rather us use sort of quantum inspired for solutions that get you basically halfway there or prepare you, right? And the way what I'm seeing in the market is that, we're telling people where quantum will be able to get them, which is this high, right? When quantum hardware is there. And it will be able to be better than where classical is, the state-of-the-art classical is today, which is here. But most companies are actually down here, right? So they're even lower than the state-of-the-art classical. So I'd rather, quantum inspired or quantum hybrid or some other adjective be used to represent solutions that essentially elevate companies to the classical state-of-the-art. So quantum inspired, in most of the ways that's been used today, it actually doesn't do that. It's almost kind of the worst of both worlds. At least that's my take on it.
Yeah. Josh, I'm curious on your perspective of this. You have a comment on the quantum inspired?
Yeah. I don't have a comment here, no. I suppose the work we're mainly exploring on our side is on the hybrid quantum classical. So I think we're still at a stage where it's very much an open question what you can do with including quantum aspects into classical workflows. There's been a lot of research into the types of setups that this might work best for. So I think there's been a lot of discussion about classical data versus quantum data and hybrid quantum classical workflows. But I think what we're missing in the literature still is an exploration of the fundamentals. When you're thinking about workflows like optimization and quantum machine learning, what are the key quantities we want to include in classical workflows from the quantum side, and what are the advantages? Are there advantages in the expressivity, what we can do, how we can add benefits that we wouldn't see classically? So I think this is what I'm discussing more with customers on a day-to-day basis. I don't have too much insight, unfortunately, on the quantum inspired side.
Okay. Thank you very much. That was insightful. Mark.
Yes, at Quantinuum, we only work on quantum applications. And so unfortunately, I really don't know very much about quantum inspired. We're really looking for harnessing the potential of quantum. And this might include hybrid, of course, especially in the near term with NISQ devices, but ultimately we're looking for quantum computing advantage.
I see. Thank you. Tinian.
Yeah, we have worked on quantum-inspired algorithms like the Evinton's, oh, I forgot but there are some algorithms. But actually, we find that that seems promising. But like if we apply to the real-world problem, that still needs like really like 1 year, 2 years to calculate that algorithm. So that is not practical right now. So we've done one, but yeah, not right now. And I
Okay,
have same
okay.
perspective like others.
Thank you. Tim, I'm sure you have something to say on this.
Yeah, I was trying to answer a little bit in the chat directly. I mean, for sure, I actually agree with a lot of what folks are saying here. And I think it can be a term that can get used in a lot of different ways. So I posted again a link to a paper to try to at least focus in on one example where we see a quantum approach having an impact to a classical algorithm, even when it's simulated on a classical device. And in that paper, it's something that's run on a quantum device and in a classical simulator. But I think that really at the end of the day, actually, I really agree with what Yanni was saying with this. The fact is that most people aren't actually up to all the potential of just what classical can do. And so I think in many cases, what we try to recommend is just to step back one step. Don't focus too much on what it's called or like what's under the hood. It's like, is it making an impact and can it be improved? Should really be the starting place. And then, and from our perspective, that means, okay, can we make improvements by just getting like a best-in-class classical algorithm implemented in this situation? If that's the case, then that's something that we want to be doing. It's much more focused on what are the results you're getting and what are the types of improvements you can squeeze out of a customer problem, than really focusing too much on how you kind of categorize the technology that's under the hood. And frankly, I think a lot of our customers don't really, at the end of the day, don't really care if it's quantum or hamsters or whatever that's doing it, right? Is it making an impact? I think is really the
black box,
question.
basically black box. We've heard about this before, which is the value proposition there? Is the ROI there? I don't care what's inside the black box, make it work, right?
Yeah, I mean, I think that's pretty much where we come from. Yeah.
Yeah. And then I want to ask another question here in terms of, what are the gaps? What are the gaps that exist, of you 5 companies here? What gaps do you see that QED-C could potentially help with? Besides webinars like this, of course. What else could QED-C help with? What do you think? Tim, why don't you start?
Yeah, I mean, I would say that for an organization like QED-C, when we go back to kind of this key talent challenge, I think thinking about and again, actually, to not to celebrate this our own webinar too much here, but I think events like this, but then more broadly programs to think about kind of upskilling a large number of people in terms of understanding what quantum is, and then getting younger people, students, going in this direction in related fields, I think will help to alleviate what will hopefully be a temporary talent crunch, and then ultimately have a lot of people coming out of school who are thinking in this direction and really able to make a broader impact on a huge variety of applications.
Yeah, and to the spirit of that, one of the things that we're discussing for one of the future quantum marketplace webinars is workforce, right? So for the students, there's actually a lot of people in deep tech that I know that want to get into quantum, but they don't even know how, right? So we're still developing it, may ping on some of you for guidance, but we want to do one potentially in the summertime. So anyway, Josh, anything you see that QED-C could be helping with?
So something that's super important for us, I think I mentioned this during my talk, is the community engagement. So something we've discussed a lot here is the ability to help customers find the solutions they're looking for and help them even better define the problem they're looking to solve. I think this is equally something that we want to improve on the developer side. So for us building these tools,
Yeah.
we need these insights to see how people want to use them and what they want to solve. And so the feedback is two-way, it's not one way. In the same way, we want to provide feedback for customers who are looking to engage with quantum computing. We also want to have that feedback ourselves to see what people want to do, what problems are important, and what uses and needs are important so that we can take this back and integrate this into our quantum software. I think it's important that the quantum software is not something that is developed in a vacuum and then we come forward and present this to interested parties, but it's a two-way discussion.
Yeah.
And QED-C, I think, can help a lot with that.
Yeah. Mark, you want to comment on that?
Yeah, so to answer this, I'm going to refer back to a slide that I noticed you skipped about misunderstandings in the community. About 99% of executives that I speak with, they seem to believe that quantum is simply a buzzword that we add to seem cool. And then it just means like a faster computer or something.
Yeah.
And so I'm trying to explain to it's fundamentally different, and we can use it to solve problems we never could have hoped to have solved using normal computers. And so I think just doing events like this and creating awareness that this is a big deal, even if they can't solve the problems today, in a few years, we think they can. And this would kind of diminish some of the hype that I think has crept up. Yeah, just education of the community about this.
Yeah, great. Tian'an.
Yeah, I'm most excited in the standard benchmarking. So I think someone commented that the benchmark of our software or algorithms is what I consider most important. So give an example of the machine learning. So for example, in machine learning, there's an image recognition competitions. So every year there's a competition that everyone works on that. And in some like 2016, the image recognitions beat humans, and then it's like working on, and that's after the image recognition is done, they move to like the movie recognitions, kind of like that. So kind of that is the transition of the, I'll say, the benchmarking, and kind of if we set the benchmark, like everyone, like the startups or the academia will work on that, and that will dramatically improve in that direction. So I think that setting up that benchmark and making standard benchmark data sets for like the chemistry or machine learning optimization, I think it's all okay. So, but it's what I think the setting up that is really important. So yeah.
Yeah, thank you. And QED-C has done a lot of work in that area, and I think it's going to continue. Yanni, you have any feedback for QED-C, how it can help?
Yeah, so first of all, let me just say, yeah, the benchmarking is absolutely essential, but we should actually make a point to make it application specific benchmarking, right? So the benchmark should benchmark, you know, how big of a molecule can you simulate, right? That's the key thing. Or, you know, how big of image can you recognize, or can you recognize a specific feature in an image, or how big of a portfolio can you evaluate the performance of a certain portfolio, right? I mean, that's kind of, in my mind, the key thing, right? Not some sort of more internal characteristic of the device or the algorithm, right? It should be like a business application benchmark. I also agree with all the comments on the workforce side. The last thing I'm going to say, if we get 3 wishes, so the top 2 are in fact benchmarking and workforce. The third wish is to get the government to invest directly in software. I think the level of investment is smaller and the ROI is potentially much bigger. So we need your help to get the government. The government is actually, and all governments, and not just the US government, but you know, if you look at, you know, EU government programs and other programs, they all talk about investing in the next big thing in hardware and getting, you know, funding to the labs and so on and so forth. But as I said earlier, if you can get investment on the software side and can have like a 10x improvement on the algorithmic side, it's almost like building a 10x larger quantum computer. So it's like you can get a lot more by investing on the software, I think.
Yeah, thank you, Yanni. Tim, you seem to have a comment on these last couple points. You want to just add to it in terms of the workforce, in terms of Yanni's last comment there.
I just was giving the big thumbs up to making sure that that the benchmarks are application centric. We're 100% on board with that, and I think it's a really good point, because you can get lost in it's fun in the kind of the nerdiness of quantum devices, and you kind of get you can get lost in the weeds, but at the end of the day, sometimes it reminds me of kind of the megapixel battles of cameras, where it's like, but does it take good pictures? Sort of, so
Yeah, right.
I think we wanted to keep that perspective, and it's a great role for QED-C. So yeah, totally agree with Yanni on that one.
Okay, great. Thank you, everybody. Mark, Tian, Josh, you want to add on that? Or are you good?
I'm good. I think they said it very
Okay,
well.
great. All right, I'm just going to go briefly into, last month we had, untangling quantum computing. Definitely see that. That'll be posted on YouTube if you didn't participate in that one. That one was great, fantastic. This one has been absolutely fantastic as well. Software for quantum, and then we designed it this way where we actually went with sort of the high level of untangling quantum computing. Then we went to software, which was today. The next one is on May 5th, and that's where we're going to have just the quantum computing system vendors and potentially some of the quantum guides as well. And then we're going to actually shift into quantum image sensing after that. So with that, thank you for attending.